How dang, hey, I'll join back in a moment. I'm on the wrong Zoom. I'll be right back.
Okay. Okay, no problem.
Hello. Hey, guys.
Hi, Lee. Hey.
By the way, hey, guys. Wow, you guys are going to stretch me today. So I was practicing Jing's name last time we met. I think I have it. But
yes.
is it?
Do you remember the last time my color is pink? You know that?
Oh yeah, yeah, that's right. I was just really surprised.
What's my color today?
yeah. Well, we may have to choose something more masculine this time around. Just you were such a good sport about it last time, so that was good. Yeah. So by the way, how Tao, is that how you enunciate your first name?
How Tao, yeah.
Okay, good.
It's okay.
Good. How Tao. Well, very good, gentlemen. We'll have probably a couple more people joining, and so how Tao. If I can, I'm going to share the screen for a moment just to orient everybody before you get up and running.
Okay.
And so, let's do this. Let's get started. Let's, hey, welcome everybody. This is the CNCF Technical Advisory Group for Network. We meet every couple of weeks, and we're getting kicked off. So if you're on the call, take a moment to drop your name into the meeting minutes, and you should be able to do that. A link to the meeting minutes is in the chat. I'd like to take a moment to get to know people, to introduce folks in general. Boy, we're missing a couple of people so far. So let me yeah, you know what? Yeah. Good. Okay. So anyway, so we've got an agenda today. We've got TAG Network topics and Service Mesh Working Group topics. So for the TAG Network, we're going to hear about Fab Edge today, which is nice. Should be exciting. And then we'll also hear about, well, one of the topics we'll cover in Service Mesh Working Group is, well, a bit more about the benchmarks and the efforts that are going on there. And then hopefully we should have had a demo on Nighthawk today. So Vendu will have to pick on you about that. The implementation in Meshry, no, that would be, I guess in 2 weeks, that would work. The demo of Nighthawk though, you'll have to bear public shame for being tardy. Okay, so now that we've got some of that awkward shame out of the way, so we got Mr. Roberts with us. By the way, Joel, you're currently at Cisco, is that right? If I recall.
Correct. Yep.
Very good. Very good. Zoom. Zoom on. Somebody else is going to have to write. I can't type and talk at the same time. It's like chewing gum and trying to walk or something. It's just too much for me. So with the corny jokes out of the way, we can move on to the actual agenda. And first up is Hao Tang of the Fat Edge project. And so how did you want to introduce yourself briefly and then start to share slides and sort of roll on into your sandbox presentation?
I'd like to share screen with introduction. All of the topics covered there.
Sounds good.
Okay, can we start?
Yeah, if you would. Yeah, please.
Okay, let me share my. Hello, everybody. And first, let me try to introduce myself. My name is Hao Tao. I'm from China. First, sorry for my poor English. If you have any question, hope you can speak slowly or typing as like China. I do appreciate it. This is 4 parts. The first is the background, why we do this project. The second one is how it works. The third one is the planning, and the last one is some backup slides. The first one is the background. Actually, this is to align with the trend of edge computing, which is one of the most hot word so far. I will not spend much time on the trend of edge computing. My key point here is the project 5Edge is focusing on the edge computing scenarios. It's not for cloud computing, it's for edge computing. Moment. In edge computing scenarios, there are some cloud to edge collaborations is a must. But the network is one pinpoint here, because the network in edge computing scenarios is quite different with data center networks, which is used in the cloud computing scenarios. It has some characters. For example, the transport network is usually some Wi-Fi wireless connections. Is very weak and not very stable. It means, for example, in the normal cloud computing scenarios, the cluster requires the network is very stable. The node to node communications is stable, and but in edge computing scenarios, the network is weak, so the node will disconnect frequently. So we know in the Kubernetes cluster, if the node connect or disconnect frequently, the cluster will take actions try to evict the workload from the disconnect node. This is a difference. The second one is we know in the normal KMS clusters, the node will communicate with each other. They require the network will be bidirectional. It means any node can communicate with the others. But in edge computing scenarios, the network usually have some some different, we call it as we call unidirectional network. This means, for example, in the if we have some virtual machine or cloud machine in the public cloud, we know it has some internal private IP address. The virtual machine can access the internet, but it cannot be accessed from the internet host. This is we call network address translation. For example, in the for example, this is a typical public cloud infrastructure. The virtual machines have only internal private IP address. When it accesses the internet, the private address will be translated by the network gateway to a public address. It means the virtual machine can access internet, but the host on internet cannot initiate the connection to the virtual machine directly. This is because the NAT gateway block this kind of inbound traffic. So this is the number 2 difference. The second one is the transport network usually be public network, such as internet, which is not secure naturally, cannot be trustable. It's not the same as the data center network is, or within the data center, it can be trusted. So this is some characters in edge computing scenarios network. Is quite different as cloud computing data center networks. So it prevents we use the existing Kubernetes cluster technology in the edge scenarios. Sorry. So far, we have some projects under CNCF, such as Kube Edge, Super Edge. They have the similar ideas. They try to connect all the edge remote nodes into the Kubernetes cluster in the cloud to form one big virtual Kubernetes cluster. So so we can treat all the cloud cluster plus the edge nodes into one big Kubernetes clusters, but they don't solve the network problems. It follows the same principles as Kubernetes, because Kubernetes, we know Kubernetes shift the network work to the network plugins. We call it CNI. So we have some project to solve the control plan questions to enable the Kubernetes to be used in the edge computing scenarios. But this kind of project does not solve the network problems, but the network problems is quite different as the cloud computing data center networks. Then this comes the questions. We have the projects to enable the Kubernetes used in edge computing scenarios. But what about network? Can we have some kind of CNI to solve the network problems? This is the background of this project. We want to work a CNI. We want to work a network plugin compatible with Kubernetes network model and to be used in the edge computing scenarios. For example, in this scroll, we can have one big virtual Kubernetes clusters. This is the benefit of the KubeEdge project. FabEdge want to do is to work as the CNI network plugin, solve the network problems. When we talk about the Kubernetes network model, we know a key point is the pods can communicate with pods directly without NAT. This is a key point of the Kubernetes network model. We want to follow this model if we say we are CNI compatible. So this is the background. We want to work out CNI, which is focused on the edge computing scenarios. This is how we do it. To be simple, FabEdge build a layer 3 data plan with tunnels. So far, we use the IPsec tunnels. And in addition to the control plan managed by other projects, such as KubeEdge, SuperEdge, OpenYACHT, they are all under CNCF. And FabEdge should be compatible with the Kubernetes CNI and transparent to applications. This is an architecture diagram. This is the cloud part. Cloud part is a standard Kubernetes cluster. And we have some cloud node. This is one cloud node, this is one node, and this is a node. And they are all edge node. They are maybe in different locations, and which are connected to the cloud or transport networks. It means we have talked about before is some weak networks. And this is one edge node, this is one edge node. All the edge nodes are joined into the cloud part Kubernetes cluster as one virtual node. So this is the whole big virtual Kubernetes cluster. But the project of KubeEdge, SuperEdge, so as the control plan, there is a green lines. FabEdge want to do is build a data plan, is a red lines. So with these red lines, the edge node can communicate with the cloud part directly, and the edge node can communicate with edge node directly. This is the FabEdge want to do. We have 3 key components. The first one is operator. Operator is a brain. It manages all the configurations because the operator have all the information of the remote nodes. So it will manage the configurations, including the tunnel endpoints, the certificate, this kind of information. And this information will be saved in the config map and secret for each remote edge node. And we have a second component called connector. This guy works as the gateway between the cloud and the edge node. It will relay traffics between cloud and edge. And it also terminates the tunnels from the edge node here. And it will relay traffic from the edge node to the other cloud node. The connector will consume the configuration information prepared by the operator. Agent is runs in each remote edge node. Its responsibility is to manage the tunnel on its own node and also the router some IP tables rules to enable the communicate between the node and cloud and its peers. Under the hood, FiberEdge leverage some existing CNI components from the community, such as the host local IPAM and the bridge. Therefore, this kind of two components is responsible for the virtual NIC creation for a pod. And FiberEdge also leverages strong S1 for IPsec tunnels. So strong S1 is a very mature VPN tool for the IPsec. And the key functionality of FiberEdge is automatically creates the tunnels between the edge and cloud and edge and edge. For this colorful lines, this kind of tunnels between edge nodes and between edge nodes and to the cloud nodes are managed by FiberEdge automatically. We have a small feature called community. This is one CRD of Kubernetes. For example, these two nodes, we enter a community, means we join the node edge 1, edge 2 into one community, then one direct tunnel between them are connected, so they can communicate directly. The connector runs in the cloud, but we don't need to run connector on all the cloud nodes. We just run connector in selectively one or two nodes. It will terminate the tunnel, and it will also relay traffic for other cloud nodes if they don't have the connector run on them. This is one example. This pod will access this pod, and the traffic will from this pod go to the connector node. It will terminate here, and the connector runs here will forward the traffic to the other cloud node and back and forth. There are project goals and no-goals. To be simple, the main goals is to enable the pod-to-pod communication, no matter the location, no matter it can be from edge to node to cloud, cloud to edge, edge to edge. All the communication between node pod to pod is in our goal, is our goals. It can be communicated directly. And some node goals is, for example, the node, one node to access one node. We know the Kubernetes is the underlay and overlay model. The pod-to-pod communication, we call it overlay. This kind of traffic will handle it by the tunnels. But the node to access the node is the underlay. The underlay is mainly controlled by the physical network environments. We cannot control it. So the node-to-node access, is not in our goals. Something in the middle is we know one pod can run in the host network model. Actually, this kind of pod uses the same network namespace as the node. It's the same as node-to-node access. So we cannot cover this kind of traffic. It means pod with host network access pod with host network. This kind of traffic we cannot handle. Most of the traffic we can handle, but a few of them we cannot, mainly for the underlay node-to-node kind of traffic. This is our planning. This project runs about a couple of months. We already have done some work. For example, we currently support Calico, we support Fnano, this kind of CNIs. We say this kind of CNI means the CNI runs in the cloud cluster, at the cloud side. we support the IPsec tunnel. In the future, we maybe add to some other tunnel technology such as WireGuard. So far we already enable cloud to edge access, edge to edge access. So far we support Super Edge, OpenYACH, and Kubi Edge. This is so far the three major edge computing framework on the CNCF. We already support all of them. We have some other features such as the NATT, some automatically managed CNI components. They come those three features. In the future, we want to add more functionality, such as heavy edge, more CNI, IPv6, etc. There are some backup slides. So far, we have some similar projects on the CNCF. The first one we found is called Edge Mesh. Actually, is a sub-project under Kubi Edge. The key difference from Kubi Edge is the first one is Edge Mesh does not follow the network model of Kubernetes. It's use some kind of proxy technology. This is a diagram. They intercept some traffic and forward it to the cloud, and edge is tightly compatible with Kubi Edge, cannot be easily used by other objects. This is number one. The second one is Submarine. It's also some project on the CNCF. My understanding is Submarine is a tool built to connect overlay networks of different Kubernetes clusters. For example, there are a couple of clusters. Submarine can connect them together to form one flat overlay networks. They used to connect Kubernetes clusters, but Fab Edge is to connect edge nodes into the cloud cluster. It's still one cluster. That's all my slides. I'm trying to. Okay.
That's great. That's great. There's a couple of questions that have come through chat, and so I'll let you read those. Maybe speak to them. Yep. Or you know what? Maybe it's probably better if I just explain a couple of them. So thanks for the backup slides as well. It's always helpful and kind of easy for people to do when they're to understand the project, when they're able to contrast it against an existing project that they might understand. So that's helpful. And so there's a couple of other projects kind of in the space that are similar in nature. So one of those is the network service mesh. It's another CNCF project. Have you come across that one before?
You say what's related to the service mesh kind of project?
Well, yeah, but I know it's a generic name, so shame on those main tabs. Try to shame them every chance I get. But,
okay. My understanding is service mesh and working at some higher layer. They works like some proxy. They intercept the traffic and forward.
Actually, let me. Sorry to apologies for interrupting. Actually, I didn't. Did a poor job of asking the question. Actually, there's a link in the chat now. There's a project. Its name is Network Service Mesh. So it is. So it's a specific service mesh project. It's one that is in some respects a service mesh for other service meshes. So network service mesh focuses on lower layers, as you were just about to differentiate. So it's focused on layer 2, layer 3, and kind of keeps it down there. And so if you haven't come across network service mesh before, it's just a good project to reflect on and comprehend. It's one of the, it'd be good to, well, let me pause there and say, are you familiar with this project, Network Service Mesh?
Sorry, I have not heard it. My understanding is 5H work and layer 3 is some IP layer. So it's compatible with the Kubernetes network model. All pod can communicate with the pod directly without NAT. So this is a layer 3 service. It's some interconnection network layer service.
Yeah, the network service mesh operates at a layer 2 and layer 3, not at a layer 7. So the network service mesh help manage and create a lot of these interfaces and connectivity like tunnels and whatnot. So all of this at layer 2 and layer 3 for Kubernetes pods.
Okay, I will study it later and come back then to Tim here.
So one question along those lines. So from a Fab Edge perspective, so how are you looking to scale this from the perspective? So some of these features could be incorporated within a CNI. For example, Calico can provide some of these features, right? So I mean, you need a management layer on top, but so how are you looking to differentiate this from some of these similar features being available in CNIs going forward, even for edge computing?
Yes, like try to. Actually, Fab Edge is not trying to replace the mature CNI such as Calico or Nano. Actually, it's a complementary to this kind of tools. For example, in the cluster of the cloud part, all the nodes still run the existing Calico, Nano, this kind of any compatible, any Kubernetes CNI plugin. It still be here. Fab Edge is just to link the remote node to the cloud. So it's for Fab Edge solves the interconnection, cross-site connections. It does not solve the connection within the cloud.
Okay, so essentially this is a management layer on top of existing deployments, so we can customize it to edge deployments across different locations?
Yes, across different locations.
Okay. So do you know about MCO project, Edge Multi-Cluster Orchestration?
Which one?
Edge Multi-Cluster Orchestration that's been adopted into Linux Foundation for networking. So it helps to take care of some of these challenges at the orchestration time. But it might be worth to check the networking aspects between the two projects.
Could you tell me the name? Right, which one?
Yeah, I typed in chat. I'll post the link.
Edge minus edge multi-cluster orchestration. You mean it's a already existing project or some generic topic?
No, it's a existing project. So originally started by Intel, and it's now being adopted by Linux Foundation for networking.
Oh, okay.
So I mean, it covers overarching topics about orchestration, along with some of the networking aspects. So worth take a look.
Okay, I have a look and come back later.
Okay.
I'm not sure, and I don't know it, but my question, I want to emphasize is the focus of web edge is connected to the focus is to connect each remote node into the cluster. It's not it's still one big cluster. It's only for the how to connect the node to the cluster. We saw a lot of projects to handle the multi-cluster interconnections, but what we do is connect node to cluster, is not cluster to cluster. Because in the edge computing scenarios, we usually have a lot of edge computing nodes spread geographically. It's only node, it's not a cluster. So a lot of multi-cluster networking tool cannot be used here.
Yeah, I understand. So some of the challenges between geographical locations, and some of these are being looked at. For example, one of the project I work in, it's called Smart Edge. Yeah, so definitely there might be differences, but it's worth to take a look to see how it's different. Yeah.
Okay, thank you.
Nice. Yeah, good. How along those same lines, there's another one, edgevpn.io. Paste the link. That's worth contrasting against. There's so in a good way, there's a lot of projects in the space. Some projects are oriented toward particular, sometimes it's the tech is about the same. Sometimes the projects though, the use cases are maybe if are vertical specific or sector specific, and that's enough to kind of differentiate them and want to encourage each to continue to do their own unique thing. By the way, the CNCF as a whole, it's okay to have duplicative projects. It's okay to, and so the CNCF isn't here to necessarily be kingmakers either, like to elevate one project over the next and things. So speaking with my CNCF hat on, this is great. So by the way, like great presentation. Thanks for walking through it slowly to make sure that people can give good feedback. It's helpful to kind of contrast, helpful for people to understand the project when you do contrast against others and sort of get really specific on like, hey, here's the niche thing that is unique, and there can be lots of overlap, or maybe there's nothing unique, and that can be okay as well. So this is good. Let me, if I may, regurgitate a couple of things just to clarify. So for Fab, by the way, I don't know that you covered the folks that are involved. So some of the contributors and some of the maintainers, or if there are any users today, just it'd be nice to get an understanding of the constituency of the community. Could you characterize that?
We are still in some early phase. We don't have we can say we have some. Sorry. we have some star and 280, and we have some contributors. We have some contributors, and we are working closely with some related communities, such as Super Age, Open Yacht, to work together to make it better. But to be honest, it's still in some early stage.
Yeah,
So
sure.
any comment?
So,
So
go ahead.
No question along the same lines what Lee asked, like any comment on like, so what companies are participating in developing FabEdge?
Oh, sorry. Could you repeat your question?
Yeah, the companies that are participating in developing FabEdge. For example, I'm from Intel. So what other companies are participating?
We have some individual contributors from. We have some individual contributors, and we work with one guy is from we have some from our after of company, but it's only a couple of a very small number. I will try to identify them. Two or three from outside of my company.
Okay, thank you.
Thank you.
Anybody else have questions? How I can't tell you how much fun is being had on this side of the table, getting to hurl questions at you. So thanks for that. This makes my Thursday much better.
Go ahead.
Nice. Yeah. Anything else to add here, Hao Tao? Not so far. I need some follow up. I need to compare some related projects a team mentioned here, and I will consolidate it together and come back to CNCF TAG later. So far, I have no any other comments. Okay, great. Thanks for that. I realize sometimes that particular activity can be a little bit sensitive or awkward to the extent that, but that means that you've got to go, that you're doing some comparisons, and it's more, or the ask there is probably more for to reinforce the understanding of the of what FabEdge is doing. In part, like. I still have a couple of questions I think about that. So one actually, another piece of feedback is two other items is, if you can give an overview of the community. So by the way, what organization do you belong to?
Borg Cloud. Borg Cloud.
Okay, good. Now, why am I not familiar with that acronym? This is
a startup company in China.
Oh, okay. All right. Very good. And good. So yeah, some data on the constituency of the community. That'd be great. A little bit of a timeline of the project. That'd be nice. Maybe some roadmap for the project. That'd be helpful to understand what the vision of the thing. You put goals and non-goals. That's really, and if that's the extent of the roadmap, like okay. Also, if you could, why are you bringing the project here? Or, like, or hey, what's why you want the project inside the CNCF? That would be good to have in a slide or as well.
Okay.
But this is nice. This is now FabEdge is orthogonal to the choice of overlay. Like I think IPsec and WireGuard were called out specifically, and so FabEdge Like, so FabEdge is not a CNI, is that right? Or is?
Actually, FabEdge is much like Finano. If Finano is CNI, we are CNI. We are. It's very similar as Finano.
Oh, Flannel, I see.
Finano or Calico. It's very similar technology, and we just focus on the edge scenario.
Nice. Okay. Well, thanks for that. That was great. It's
Thank
nice.
you very much.
Yeah. All right. Very good. Very good. And actually, there's a couple of other folks that I'll introduce you to as well, who might be helpful in giving some feedback.
Oh, great.
So, yeah.
That's great. I wait for your comments, and I can express my project more clearly and to follow the CNCF process. And we hope we can do it better working together. Yeah. Thank you.
Yeah. Yeah. This is all. Yeah. Thank you. Thank you.
Thank you.
It's great. Good deal. Well, we've got meeting minutes here somewhere. Okay, so we had a couple of other topics. So one inside of the Service Mesh Working Group. So there was an effort to, well, get a few scholarly words onto paper, maybe, and talk about Service Mesh performance and kind of the considerations that you have as you go to study this sort of a thing, and some of the tools in the ecosystem. And so that had just been released since last we spoke. And so if you're, so kudos to the S&P project for putting pen to paper. And if you're interested in it, please, give it a read. And next up, so Sunku, I put your name on this, and it's a little bit, unfair, but it is, but it's one of the topics we've been discussing inside of the Service Mesh Performance Project, and that is, well, starting with some tests and understanding that we don't have, representative workloads necessarily identified. I think we've spoke to a few of them, and we've got some sample apps of different flavors, but we've only made it so far in some of those discussions. And one of the action items that I think Navendu, maybe that you might have taken away last time we were discussing this was, well, to take the GitHub action for Service Mesh Performance and understanding the use of it and using GitHub runners or using GitHub hosted virtual machines comes with some caveats about the particular signals that come back and noisiness that might go on in that environment. But beginning there with GitHub hosted runners and maybe moving to self-hosted runners is a start, and just choosing one of the available sample apps is kind of puts us in motion. That's the topic. So I guess between Navendu and Sunku, any updates?
I mean, Navendu and I chatted over Slack, and so I think the idea here is to kind of get started on running the tests. I know there are multiple test cases and multiple ways we could, slice the whole banana, but it's essential that we get started somewhere, start running the tests and iteratively publish the numbers, optimize it. As long as we're clearly kind of documenting what we are doing, that there can always be an iterative approach to improve some of these work. I think in terms of tooling, how best to do this, maybe Navendu might know best. But in terms of test cases, we were discussing, we could start off something simple. For example, some of the work I've done, start off with a simple Nginx web server as my workload and start understanding the intricacies in terms of actual benchmarking and the performance numbers, right? So of course there are good, I mean, there can be good workloads out there. For example, that Starbench is a popular workload for microservices, or Google Boutique, or that there are some good microservices deployments out there. But we can start with anything that's simple for us, and then like the infrastructure that we need to, the book info, I guess that's the one. There's a Mojito, right? So there are multiple workloads, but to get started on the infrastructure in an automated manner, that's something that we need to get going. Navinda talked about doing this on AWS, for example, get that going. Unless we have a set of service, right, say in our backyard, which might not be anytime soon. So so in that sense, we could get something going there. So Navindu, maybe you might want to comment.
Yep. To get started with this, I think we need to make a couple of changes to the action as well to deploy the sample applications and to set up the environment as well. Like I'll get this done quickly so that we can get some initial test results in, and then move to some self-hosted runners or CNCF's machines. So yep, that's it. So the action, as you can see in the Ashley sharing, uses machine.
Let me ask you this: what changes are needed?
Yep. So the action by default only runs the performance test, so it expects the user or the environment to have an application and a service mesh deployed. So we need to account for that as well. Like we need to set up the user's environment as well.
Okay, and so
we should bring in our own cluster with service mesh and the app installed.
So for the Meshery project, which that's what this GitHub action is using underneath the covers. That project has workflows that do spin up clusters, or a cluster, and does spin up a sample app. And so it should be a pretty quick delivery on getting those together, because that would just be combining a couple of workflows. Are you familiar with those workflows that are in the Meshery project? That spin up the...
So yeah, that makes sense. But I think we should be making the action handle this. So
no, not necessarily. No. In this action, the point here is to help facilitate performance testing. And so people will bring their own cluster, they'll bring their own apps, they'll bring their own service mesh if they're bringing a mesh. And then the action will point to their endpoint. So it's intended to be orthogonal to that, so that they can test in their environment. Otherwise, if it brings the whole thing, it's like, well, then there's really no need for them to run it. We'll just run it centrally and globally. And so, yep, the act of bringing together a couple of those workflows, though, will set forth a good example for other projects to pick it up. So, by the way, so part of the goal of this project, or of SMP, and then of some tooling around SMP, like this particular GitHub action, is that each and every service mesh project would be running this in their pipeline if they're using GitHub as their pipeline. And then to be self-reporting results. And so, good. Okay, sounds like we're close. We would by the next time that we meet, we would expect to be looking at a few results. That actually brings up kind of a next, so there are results that are presented and statistical analysis performed inside of Meshery. As those, so something, Sunku, potentially for you, or Jing, I don't know if you're interested in this particular area, but if so, like, let's not be shy there and get you hip deep in it. And that is, if you think about it, so over time, as these tests are run, each individual test, however long it's run with whatever configuration that it's running under, that analysis is captured and persisted. Maybe we'll be able to reflect on this as we get into it a little deeper, but is that format enough? Like, is that the format that you would just review time over time, or is there a higher level aggregation? Does the SMP project need a public facing dashboard of the performance of the ongoing performance tests that are being run against different service meshes and in different environments? Like, is that an effort worth putting forth? It's probably not by the way, when you think about it, it's probably not a difficult effort, because the output of the statistical analysis that's done is captured in service mesh performance specifications, captured in that output format, which is, JSON or YAML. And the service mesh performance site itself is just Jekyll site, simple Jekyll site, works with YAML, works with JSON. So to, have a dashboard there on the SMP spec.io website, that might be, what do you guys think about something like that?
Yeah, I think if it's not a heavy lift, yeah, that would definitely help. I think as we progress with it, some of the tests and creating a dashboard, I think that's the kind of landing page for everybody to get started with. Right.
Nice. Okay. Any naysayers on anybody dissenting? Just as a point of reference, so this Meshry as a tool also does conformance testing for all of the participating service meshes in SMI, and it has a GitHub. There's a GitHub action for this. Those two of the teams today are able to run the action and report their results, and then those results are displayed here. And so, just kind of an example of how that has been done for SMI. So hopefully, something similar, a little more, maybe some more metrics for SMP. That makes sense. Yeah. So I guess I'll try to type out some of those notes, because I think I've already proven I can't type and talk at the same time. But if people have advanced thought as to what that dashboard might look like, doesn't have to be fancy, but what metrics to expose, and those should be pretty similar to the metrics, the metrics that are being populated into the SMP proto, are the same metrics that would be available to show in the graph, but maybe not everything needs to go into the dashboard. I don't know. Food for thought.
Yeah, agree. I mean, we can start off with these at the basics, transactions per second and the latencies, and as we go, top of my head, I couldn't think of more, but I'm pretty sure there can be a couple more that are valuable, so I can get back to you on that.
What's a different word for dashboard? Like, if it's just because it's not dashboard is more like implies kind of a real-time health thing, and this is more like
a summary page, or I don't know, activity page, or a results page. I don't know. Yeah, we can be creative.
Naming is hard. Yeah. We're just at the top of the hour. Let me step back and do other people have items that we didn't cover today? Do other people have questions or comments on what we should talk about next time? So, Jin, it's not because your favorite color may or may not be pink, but it's because it's because you've been so good natured about some of this and been kind of interested, I think, in SMP and some of the tooling. So I just wanted to make a public note that that will reach out and try to get you involved. Actually, this particular, like even just sort of focusing on getting some initial tests running. If you haven't worked with GitHub workflows or GitHub actions before, it's an opportune time to learn, and they're not too difficult either. So.
Yeah, I'm sorry, I'm not familiar with GitHub action before, but I can have a look and come back to the stack.
Nice, perfect. That's great.
Yeah.
Well, there's a number of folks who are willing to help too. So, all right. Sunku, Joel, Pranav, we miss anything?
Nothing that I could think of. But yeah, so we definitely need to kind of drill down on how we're going to run some of these tests, the complexity surrounding it.
Yeah, totally. I think, thanks for that. I totally agree. I think in part the complexity surrounding it has been, well, in part what has pushed off some of the publication of the results. But yeah. All right. Fair enough. Hao Tao, I don't know if he's still on, but it was a great presentation. Catch you all in a couple of weeks. Very good. All right. Thanks, guys. See you all later.